It's very easy to install the jpf-hj data race detection algorithm framework. All you have to do is clone the repository and then make sure you have the right Java version. If you see this, you are good to go. If you don't, you can go to Oracle's website. The link is provided in the README. Download the tarball and unpack it. Add that to your path. Get this message of version and you're good. Once you've got that, all you have to do is take the Gradle wrapper and build. It will automatically detect what files are missing, download the missing ones, and install. Build successful. Once you've got it installed, it's pretty easy to get started. Read the README and you will see there's instructions here. Very nice command here, the run interactive. Go ahead and run that. There's only one search method implemented, so the default is what we'll need. This is your data race detector. You can use HB or Fast Track or a series of others, which I will show you later. We'll use HB for now. You can say whether you want dport or not, whether you want to use doesn't commute type dport or not, whether you want to output the benchmarks to a file, we do, whether we want to debug, in this case we will want to debug, and then the benchmark. I'm going to run add no, which is a simple program that does not have a data race. So finish there, no errors detected. You may want to run the same setup more than once. In that case, you can specify the parameters in the command line. So again, we're going to use the Gradle wrapper. We're going to use run. We're going to specify the detector. We use HB for this one. We're going to specify that we want debug to be true. And we want the benchmark simple, 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 which is a program that contains a simple data race. So that finished and it detected the data race. You can check out the output for each of the tools. If you set the flag true for benchmark output, you should see a file like this, the benchmark output HB detector. And if you look at that, it has a comma-separated list of each run of your benchmarks. If you want to run the same command again, it will concatenate all new results. So when this one finishes, we should see in that same file there is a new entry. Also, if debug is true, it will emit dot files for your graphs. So that's in the dots directory. So let's look at the one that was emitted just before the data race. And it's fairly simple. There are 3 threads here. The green lines are when a new thread is launched, an async. The red lines are when they join back together, and the black lines are continuation in program order. We can look at the race detected version. It's very similar. The only difference you'll notice is that 4 and 7 have been marked red, and that shows that when the algorithm intersected the access sets contained in 4 and 7, it was non-empty, and that's why it declared the data race. So I'm going to show you the tools that are available. How it works is it actually searches for the classes it needs at runtime. So anything that ends with detector and extends detector is considered to be valid. We can just run a find by name *detector.java, and that will tell you everything that you can run. So I'm going to show you just how easy it is to get a new prototype running in this development framework. I have an idea for an algorithm that is sound but not complete. It's just going to return true. So I'm going to code that up. I'm going to go in the source directory and make a new directory. I'm going to call it SNC for sound and not complete. I'm going to copy a few files for reference. So we'll go to util and get the detector.java. We're going to copy it as sncdetector.java. And from HB, from graph HB, we'll get the HB search. We'll call that SNC search. So let's look at the search first. The first thing we're going to want to do is change the package to SNC. We're still going to need to import util search. These will need those. We'll change the name here on the constructor and the detector that it's going to call. And that is all you need there. And then we'll look at the detector. Again, we'll change the package. We probably won't need these, but we will need util detector, because we are going to extend this. So SNC detector extends this. So we just have to look and see what things we need to change from the default. So we're just going to override hasRace to return true. I think that's all we're going to need to change. So we can just delete everything else. Let's see if it builds. So we'll use the Gradle, clean build, and it looks like it's successful. So let's go ahead and run. Detector is SNC. It'll figure out the rest from there. And the benchmark, simple, simple, simple. And there it's going. We're up and running. Simple as that.